Welcome to Kubernetes Interview Crashcasts, your go-to resource for acing those tricky Kubernetes interviews. I'm your host, Sheila, and today we're joined by Victor, an experienced backend engineer, to tackle a common interview question. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to be here and share my knowledge with the listeners.
Great. Let's start with our question for today. What is Kubernetes and why is it used in modern application deployment?
That's a great question, Sheila. At its core, Kubernetes is an open-source container orchestration platform. It was originally developed by Google and is now maintained by the Cloud Native Computing Foundation. Kubernetes, often abbreviated as K8s, automates the deployment, scaling, and management of containerized applications.
Excellent start, Victor. Could you elaborate on why it's become so popular in modern application deployment?
Certainly. Kubernetes has gained popularity because it addresses many of the challenges faced in modern application deployment. It provides a consistent environment for applications to run, regardless of the underlying infrastructure. This consistency makes it easier to move applications between development, testing, and production environments. Additionally, Kubernetes automates many operational tasks, reducing the burden on development and operations teams.
That's really helpful. Can you give us some specific examples of the key features that make Kubernetes so useful?
Of course, some key features include automatic scaling of applications based on demand, self-healing capabilities where it automatically restarts failed containers, and rolling updates that allow for zero downtime deployments. Kubernetes also provides service discovery and load balancing, which are crucial for microservices architectures. Another important feature is its ability to manage storage, allowing for persistent data in containerized applications.
Thank you, Victor. Now, let's dive a bit deeper. Can you explain the basic architecture of Kubernetes?
Certainly. At a high level, Kubernetes follows a master node architecture. The master components form the control plane, which makes global decisions about the cluster. These include the API server, scheduler, and controller manager. The nodes are worker machines that run the actual applications. Each node has a kubelet, which manages the node and communicates with the master, and a container runtime like Docker.
That's a great overview. How about we explore some real-world use cases? Can you give an example of how a company might use Kubernetes?
Absolutely. Let's take a large e-commerce company as an example. They might use Kubernetes to manage their microservices-based application. During normal operations, Kubernetes ensures that all services are running smoothly. When there's a spike in traffic, perhaps during a sale, Kubernetes can automatically scale up the necessary services to handle the increased load. If a service fails, Kubernetes can automatically restart it or redirect traffic to healthy instances. This allows the company to maintain high availability and performance, even under varying conditions.
That's a compelling use case. Now, let's consider some edge cases. How does Kubernetes handle network partitions or split-brain scenarios?
That's an excellent question, Sheila. In a split-brain scenario, where the cluster is divided due to network issues, Kubernetes uses a consensus algorithm to maintain cluster integrity. The etcd distributed key value store, which backs Kubernetes, uses the Raft consensus algorithm. This ensures that even if some nodes are unreachable, the cluster can still make decisions based on the majority. However, in severe cases, manual intervention might be necessary to recover the cluster fully.
Thank you, Victor. That's a great explanation of a complex scenario. As we wrap up, could you share some best practices for working with Kubernetes?
Certainly. Some key best practices include using declarative configuration with YAML files, implementing proper resource requests and limits for containers, using namespaces to organize resources, and implementing robust monitoring and logging. It's also crucial to keep Kubernetes and its components up to date to ensure security and stability.
Excellent advice, Victor. Now, as we conclude our interview, I'd like to offer some feedback and tips for our listeners preparing for Kubernetes interviews. Victor did an excellent job of starting with a high-level overview and gradually diving into more complex topics. This approach is crucial in interviews. Start broad and then narrow down based on the interviewer's follow-up questions. Remember to highlight real-world applications and be prepared to discuss potential challenges and solutions. Don't be afraid to admit if you're unsure about something. It's better to be honest and show your thought process. A common pitfall is focusing too much on technical details without considering the business value. Always try to relate Kubernetes features back to how they solve real-world problems or improve operations. Lastly, stay up to date with the latest developments in Kubernetes. The ecosystem is rapidly evolving, and showing awareness of recent changes or upcoming features can really impress an interviewer. Thank you, Victor, for joining us today, and thank you to our listeners. Until next time, this is Sheila signing off from Kubernetes Interview Crashcasts.